Alright guys, welcome to our Review Test 5 study guide. I'll be doing the even ones. Those are the ones you're required to do. The odds are left for you as extra practice. The answers are included if you're interested. First thing we're going to be doing is reviewing how to use the elimination method to solve a system of equations. On the test, all you need to do is solve for x, but typically when you do solve a system, you solve both x and y. So I'm going to solve for both, but you really just need to solve for x. Here we go. The way that this strategy works is you pick a variable to cancel. So I'm going to go ahead and pick the y values here. And then what I'm going to do is I'm going to pick the numbers in front of those, -7 and 9. I'm going to reverse them. The -7 is on the top, so now I'm going to put it on the bottom here. And then the +9 is on the bottom, so I'm putting it on the top. And what we're going to do is we're going to distribute that into the parentheses for each one. Now what this is going to do for me is it's going to end up causing the y variables to end up having the same exact number. So let's go ahead and do that distribution. I would get 36x minus 63y equals -180. And then on the bottom, I would have 49x minus 63y, left off my 3 there, equals -63. And like I said, now notice my y variables have the same exact coefficient. Now we're going to do another step. The next step is to multiply both sides, or one of the equations, I should say, by a negative. I'm going to go ahead and multiply the bottom by a -1. And what that's going to accomplish for me, you shall see in a moment. The top equation is going to stay the same. The bottom equation is going to be almost the same, it's just that all the signs will be opposite now. Now what did that accomplish for us? Well, now that makes these opposite signs. And therefore, if I were to combine these together, they would cancel each other out, and that's exactly what I'm going to do. I'm allowed to combine these so long as I combine everything else. So if I combine these x's together and this 180 with the 63 there will be good. So 36 take away 49 would be -13x. And then 180 minus 63, that's -117. Next, what we're going to do is we're going to divide both sides by -13, and that'll solve for x. Now, if we were taking the test right now, we would be done if you solve for x first, because that's all you have to do. And that leaves me with 9. Now, I'm going to go ahead and solve for the other variable now, but on the test you don't really have to if you've found x right away, okay? To find the y variable, you're just going to go back to one of the original equations. I'll pick the one on the bottom here. And we're going to be replacing the x with what x equals. And x equals 9, so that would be -63. And then we're going to go ahead and just solve for y using some basic algebra here. And we get 8. So we have y equals 8 and x equals 9. So that's the elimination method for solving a system of equations. And if you want to see some steps on how to go about doing that, go look back in your 1.4 notes. We have some actual written out steps there. And those steps will also help you out with the next problem, which is to solve another system of equations, but with a different method. This is the substitution method. Now in the substitution method, the first thing you do is you find the variable that is isolated, meaning all by itself. You're going to recognize what it equals. In this case, y is equal to 3x plus 17. And then that means we're going to replace the y in the other equation with 3x plus 17. Why are we allowed to do that? Because y equals 3x plus 17. So I can replace y with 3x plus 17 because they're equivalent values. If I do that, that's what the bottom equation would turn out looking like. And then we go ahead and just distribute. That's a big one. What is 7 times 17? 119, I think. And just so you guys know, you shouldn't be getting fractions on these problems. It's not so much that it's impossible to get a fraction. It's just that with the software I use to make your tests, you won't get a fraction. So those go away. I'll combine these and I'll get negative 24x. Next step is just to divide both sides by negative 24. And that gives us a nice clean answer, no fractions, like I said, of x equals 4. And then what you do after that is just go ahead and take that answer and plug it into one of the original equations. I'll use the top one. It looks easier to me. And there's our y. Once again, it's just asking us to find the x coordinate, so we really could have stopped here, but I just want to show you how to find the other variable just in case you may need to do that at a future time. All right, let's go ahead and move on to number 6. Number 6 is asking us to evaluate a function. So they give us a function, and then they say find w of 1. And basically what that means is we're going to take our function and we're going to replace whatever variable they have in parentheses there, the a. We're going to be replacing that with whatever number they have given us, which is 1. So I'll be plugging 1 in these spots. And our job is to simplify it. The left side just stays just like that. You don't do anything with the w of 1. But for this side, we're going to have to simplify it. So starting in our exponent here, we have 3 times 1, which is 3, take away 1, which is 2. So I have 2 times 2 to the second power. Order of operations is you do exponents first. So that's going to be 2 times 4. And then you can do multiplication at the end, which is 8. So basically just plug in the number that they give you and then follow your order of operations until you get to your final answer. That's evaluating functions. So for the next few problems here, we're going to be doing function combinations. They give us two functions, f and g, and they ask us to find this value. So we want to do 2 times f of a. I'm just going to put a blank there for f of a, minus 3 times g of a. So 2 times f of a, here's my 2 times f of a. We're replacing the f of a with 4a minus 5. And we're replacing the g of a with a cubed plus 2a squared. And from there, we just need to simplify it. So we'll distribute and if possible, combine any like terms, but I don't see any like terms that I can combine here. But I will put it in descending order. Whether or not the test will do that or not, I can't say. Sometimes it does and sometimes it doesn't. But descending order means you go from the highest exponent to the lowest exponent. I'll go ahead and do it just in case. All right, and so there's that. Let's go ahead and move on to our next question. Number 8, another function combination. This is what we call a composite function. Basically, I'm plugging one function into another function. And in this case, I only have one function. Now, on some of these problems, matter of fact, I might just go back and do 9. Oh, 9 is the same. Anyway, basically, a lot of times they'll give you two functions for these, and you'll be plugging one function into another. So in this case, they're only giving me one function, and you're plugging that function into itself. So for this thing here, how I taught you guys how to do this was to start by writing your inside function first. So that would be g of n is equal to n minus 3. So here's my inside function. So I wrote that first. The next thing we do is we write the outside function. In other words, that's the one that's not in parentheses, but it's the same function. So now we write the outside function. So I'm going to write the same one again here because the outside is the same thing as the inside. But with one little difference, we're going to replace the variable with just parentheses. So replace the variable with just parentheses. So instead of g of n this time, I'm just going to put g of parentheses. And instead of n minus 3, I'm going to put parentheses minus 3. Okay, so step 1 is to write out your function, the inside function. Step 2 is to write your outside function, replacing the variable with just parentheses. And the reason we do that is because of the third step, where we take this side and drop it down into the parentheses. So we have g of n is equal to n minus 3 minus 3. Okay, this side doesn't change. We just leave it just the way you see it there. Over here, though, if you can simplify, then go ahead. Minus 3 is minus 6. Okay. If you're looking for any extra help with these types of questions, you can go look at your 2.5 notes for some extra examples and extra explanations. Okay. Let's go ahead and take a look at number 12. Number 12, notice that this is a lot like number, I think it was 8 that we did earlier, but there is a difference. Instead of there being an x here, now there's a number. Okay, so here's how I like to handle these. I'm going to start by finding f of 5. So I'm going to go to my f function up here, and I'm going to plug 5 in for x. Now 2 times 5 plus 1 is 11. So f of 5 is 11. So that means we're going to have 3 times f of 5, 3 times g of 5. Now I already know f of 5 is 11. I'm going to do the same thing with this one. Now I'm going to find out what g of 5 is. So g of 5 is equal to 5 squared plus 3 times 5. Just plugging 5 in for x there. That gives me 25 plus 15, which is 40. So I'll be plugging that in here for the g of 5. And then from there, we just need to do our math to solve it. I've got 33 minus 120, which comes out to be negative 87. Okay, so I found f of 5 and g of 5 first, and then I plugged it into these expressions, and then I solved. All right, let's go ahead and take a look at number 14. One more. This one's a lot like number 12, but it's just, once again, instead of an x, there's a number. So how I like to do this is I like to start with the inside function, just looking at g of negative 3. And I want to find out what is g of negative 3. Well, to find that, I would take my g function, and I replace the n value with negative 3. In other words, just plug it in. So I get negative 6 minus 2, which is negative 8. So apparently, g of negative 3 is negative 8. So now that means I can replace this g of negative 3 with what it equals, negative 8. Now I need to find f of negative 8. And what that means is I'm going to be plugging negative 8 into the f function. So 2 times n plus 5, we're plugging in negative 8 for the n. That's negative 16 plus 5, which is negative 11 is our final answer there. Move on to number 16. All right, so this thing says solve the equation with the quadratic formula. Now, before you can begin, you need to get it in standard form, which means it needs to be in descending order and equal to 0. So I'm going to start by moving the 12 in to the other side. So I've got 10n squared minus 3n plus 14 equals 12. And I also want to move the 12 over here to the other side. Once you've gotten this far, we're going to use the quadratic formula to solve it. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is 10, b is negative 3, and c is 2. So let's begin. I like to start by rewriting the formula, but with parentheses in place of the variables. And then I like to plug them in. So the b goes in the first 2 spots. The a goes next and also on the bottom. And then finally, the c comes last. When I simplify these, I simplify the following 4 groups of numbers. So the first one, negative negative 3, is just positive 3. The next one, negative 3 squared, is 9. The next one, 4 times 10 times 2 is 80. Now you got to be careful on this step because sometimes one of these numbers is negative and you might end up with a negative number here. And if you do, then it's going to combine with this minus here in the middle to make a positive. So you got to watch out for that. On the bottom, we have 2 times 10, which is 20. All right. The next thing I'm going to do is I'm going to be working on the square root part. The square root's going to require some special attention. So here we go. First thing I'm going to do is I'm going to do 9 minus 80, and that would be negative 71. Now, anytime you got a square root with a negative inside, that's an imaginary number, and we handle that by just crossing off the negative and putting an I on the outside. The next thing you're going to try to do is break down this number and take out your pairs. Now, in my example, 71 does not break down. That's a prime number, so I can't break mine down. So actually, I'm done. But do be aware, you may have to factor and take out your pairs in these particular problems. All right, so now that that's done, let's go back to the rest of the problem here. So we just discovered that the square root part now will look like this. Now, there are times where if you have a number here, which I don't, and this number here, as well as this number and this number can all be divided by something in common, then you need to do that. That's called reducing, okay? Another thing that could happen is that if you have a negative on the bottom, like let's say this was a negative 20, which it's not, but let's just pretend for a second that it is, you would take it off here and put it up here. That's typically how they'll write their answers. But for me, this is my answer, and we'll leave it at that. If you'd like to see some more examples of these for some extra practice, I would encourage you to go back and look at your 4.1 notes. So for number 18, this is another quadratic equation, and technically we could solve this using the quadratic formula, but we're not going to do that. We're going to do what the directions are saying. The directions tell us to solve by taking square roots. You're allowed to use this method anytime you have just a p squared or an x squared, and there's no other variable. Okay, so compare this now with the last problem that we did. Let's back up a little bit to 16. There was an n squared, but there was also an n. And when you have that, you really have to use the quadratic formula, or sometimes you can use factoring. But in this case, whenever you have just a square with no non-square there, you can just solve it using some basic algebra. So what do I mean by that? Start by getting this p squared by itself. So I minus 1 on both sides. Then I divide both sides by 81. And I've got p squared by itself now. That reduces to 1 over 9. The next thing you're going to do is you're going to take the square root. Now, a couple things you got to remember when you do that. Those cancel, leaving you with just p. On the other side, anytime you square a root like that in the process of solving, you get two answers, a plus and a minus. Also, when you're taking the square root of a fraction, you're going to want to think of that as taking the square root of the top and the bottom separately. Okay, now, in my case here, my square roots turn out pretty nice. Square root of 1 is 1, the square root of 9 is 3, and I'm done. Just to be aware, sometimes you may not have square roots that work out perfectly. Like, for instance, you might have like an 8 here or something. In that case, you got to break it down and take out your pairs. Another thing you might want to remember is if you ever end up like with an answer like this, you're not supposed to have square roots in the bottom. So one of the things we talked about was how you rationalize, which is multiplying that number on the top and bottom. And when you do that, you get 3 radical 2 on the top and the bottom. The square root of 2 times the square root of 2 simplifies to just 2. So that's called rationalizing. So you want to be aware of that. That has nothing to do with my problem that I just completed. This is my answer. I'm just giving you guys some information in case you want to do some. Once again, if you want to see more problems like this and practice these, I would look at the 4.1 notes. All right. Let's go ahead and take a look at number 20. This one's asking me to sketch a graph of the function. Now, this is a quadratic, and quadratics can come in two forms. They can be in standard form, like this one, which is what this equation is in, or they can be in vertex form, which is like this. We're going to do one of each on this review test. So let's begin. How do you graph a quadratic that is in standard form? The first thing you're going to want to do is find the vertex. Okay, to do that, you have to find two parts of the vertex. Your vertex is a point that has two values to it. We'll call them h and k. To find the h value, you're going to use this formula here. H is equal to negative b over 2a. So the b, once again, is the middle number, and the a is the first number. So negative 12 divided by negative 4 is 3. So that's the first part. The next thing we want to do is find our k. To find your k value, what you're going to do is you're going to be plugging 3 into the original problem. Now in this step, you got to remember your order of operations. You're going to do the exponents first. Then you're going to do your multiplication. And I end up getting k equals negative 2. So my vertex then, hk, is the coordinates 3, negative 2. The next thing that we need to do is we need to look at the a value. That's the number in the front. Okay. On a quadratic equation, the a value tells you a couple of things, but I think all we really need to pay attention to for these problems is if it's positive, that means you have a happy face parabola, and if it's negative, that means you have a sad face parabola. So for our problem here, it's negative, so I've got a sad face parabola. We now have enough information to graph it. So let's review the steps really quick before we do that. Find the vertex using the process shown below. Next, decide whether you have a happy face or a sad face parabola by looking at the a. Let's graph it. To do that, we plot our vertex, 3, negative 2. And then we're just going to draw a sad face parabola just like that. And we got our answer. Okay, so that's how you graph in standard form. Let's go ahead and take a look at the next example, which is graphing a quadratic that is in vertex form. For these ones, in my opinion, it's a little bit easier because finding the vertex is much simpler. You just look at these numbers here and here. You just have to remember that you're going to take the opposite of that number there. So it's negative 2 for the h and positive 2 for the k. That's our vertex. As you can see, once again here, I've got another sad face parabola because that's still the a value, and the same rule applies there as it did on the standard form one. So we're ready to graph. Negative 2, positive 2 would be here, and we have our sad face parabola, and we're good to go. So that is graphing in vertex form, a little bit easier than graphing in standard form. Let's go ahead and take a look at number 24. We're looking at trying to find a fourth root of this number here. So it's like a square root. It's just that instead of looking for pairs of numbers, we're looking for groups of 4 numbers that are the same. So the first thing I'm going to do is I'm going to break the number apart here, 486p to the 4th. First of all, let's split the number away from the variable. Now, obviously, p to the 4th means you just have 4 p's that are being multiplied together, right? 486, we got to break apart by multiplication. I know 2 will go into that because all those numbers are even, so it's going to be 243. 243, that's not a very friendly number, but I think it can be divided by 3. Let's see. 3 goes into 24 8 times, and then 3 once. Okay, there it is. And then 81 is 9 times 9. And then 9 is 3 times 3. So our goal is to break it all the way down. And you're only going to look at the ends of your branches. So we don't look at the other numbers because those already got split apart into the smaller pieces. So we have the following situation. We have a 2, and we have 1, 2, 3, 4, 5 3s. That's a lot of 3s. And we have 4 p's. And we're looking for the fourth root. And that means we're looking for groups of 4 identical values. So we have a group of 4 there. And for every group of 4, I can cross off the group and put that number outside of the radical. Here's another group of 4, so I can cross off that group and put that value outside of the radical. I'm left with a 2 and a 3 on the inside, which is 6, and at that point, we're good to go. That's the end of it. All right, here's another one. You could really handle this the same way. I'm going to show you guys how to solve this in 2 different ways. This problem has a really easy way to solve it, but also has a more challenging way to solve it. But the challenging way is important because not all problems can use the shortcut I'm going to show you. So I'm going to start by showing you the long way just so that you know how to do it if you need to. But if you have the shortcut scenario, which this one is, I'll show you how to do that also. So first of all, what we want to understand is I gave you guys a rule a little while back. And the rule was something to this effect. If you have a to the t over b, then you could rewrite that as a root, where the b is your root value, the a goes here, and the t goes here. Kind of easy to remember because t stands for top, b stands for bottom in the fraction, but then when you write it out this way, it spells the word bat. It's kind of a nice little way to memorize it. But anyway, knowing that then, I can rewrite this expression. That would be the a value. The bottom number goes here, and then the top number goes out here. Now, I don't really need to write a 1 if it's a 1. If it was a 2, you would want it there, but in the case of a 1, it doesn't really matter. So I'm looking for groups of 3 that are the same, and I have 9 x's in there being multiplied together. And for every group of 3, I can take an x out. So here's a group of 3, so I can take an x out. Here's another group of 3, so I could take another x out. And here's another group of 3, so I could take another x out. Now you'll notice that there's nothing left inside the radical, and when that happens, you can just get rid of the radical. And so my answer is x times x times x, which is x to the third. Now that's the long way to do it. So the long way is to transform the exponent into a root, and then to simplify the root. Okay? Now the short way. The shortcut only applies if you have a variable with a power being raised to another power. Okay? And here's how that works. The shortcut is multiply the 9 times the 1/3, which 9 over 3 is just 3, and we're done. Same answer, much faster. But once again, that only works because there's no number in the front here. You know, if I were to put like an 81 here, then I would encourage you guys just to solve it the other way that I showed you, okay? But in this case, you can use the shortcut. All right, let's go ahead and move on to number 28, solving equations that involve rational exponents, meaning exponents that are fractions. So the first thing you want to do is get rid of everything that's outside of the parentheses. Now here's where the magical move comes in that tests your knowledge of your ability to actually do these problems. What we want to do is we want to get rid of that 5/6 power. The way you do that is by raising this whole side to the opposite power, the reciprocal, 6/5 power. Because if we do that, you would multiply these, and 5/6 times 6/5 basically cancel each other out. And I'm allowed to do that so long as I also raise this other side to the 6/5 power. And what that's going to leave me with then is 32 to the 6/5 power is equal to negative 16 minus 4n. Now, before I go any further, I'm going to simplify this expression really quick, because it can be. Using the a to the t over b is equal to that rule that I shared with you earlier, I can rewrite 32 to the 6/5 as the fifth root of 32 raised to the 6th power. If you were to break apart 32, you would end up with exactly 5 2's. So I can take a group of 5, cross off the group, and put the 2 on the outside. Since there's nothing else left in the radical, I can just put 2 now, but we don't want to forget that 6th power that's on the outside. And now I just do 2 to the 6th power, which is 64. 2 times 2 times 2 times 2 times 2 times 2. Now I've got 64 here instead. From there, we're just going to go ahead and solve it using the old school algebra from Algebra 1. We're going to start by adding 16 on both sides, like so. And that's going to end up giving me 80 equals negative 4n. And then we just divide. And final answer there would be negative 20. Okay, so I would say the big things you want to pay attention to on this are getting rid of the outside numbers first, if there are any, and then raising both sides to the reciprocal power, and then finally using the bat rule to simplify that expression there. The rest of it is pretty much Algebra 1. All right, let's take a look at number 30. This one says, remember to check for extraneous solutions. So what that typically means is that it's possible that the answer you get may not be allowed. So once you get the answer, you got to plug it back in and see if it makes a false answer. So this rule is a lot like the other one. We're going to start by adding 6 to the other side. We want to get rid of any number that's outside of the radical. Gives me 3. Now, how do you get rid of a square root? Well, the way you get rid of a square root is by raising it to the 2nd power. Second powers cancel out square roots, which I'm allowed to do so long as I raise both sides to the 2nd power. So now I've got 10p minus 1 equals 9. Next, we're just going to go ahead and do some basic algebra here to get the p by itself. And we get p equals 1. Now, once again, we want to check to make sure that this is a good answer, because it's possible to get an extraneous solution. And how do I know that? Because the directions tell me it's possible to get extraneous solutions, so let's make sure we don't have one of those. 10 times 1 is 10, minus 1 is 9. The square root of 9 is, in fact, 3. And then negative 6 plus 3 is negative 3. Looks good to me. Didn't have any problems along the way. One of the things that could happen is like probably in this step here, you could end up getting a negative under the root, which is no bueno. Can't have that. That would be an extraneous solution at that point. Or if another thing that could happen is the two sides don't come out equal. That's another thing that could happen. So 2 things to look out for as you're checking for extraneous solutions. But that'll do it for our review. So hopefully that was helpful, and we'll see you guys in class. Have a good one.